Let's look at the tangent function. Once again, the y-axis represents the tangent value. The tangent value is opposite over adjacent. Now on the unit circle, opposite over adjacent is y over x on the unit circle. And y over x tells me slope, or the slope of the angle. We could also think of that as the slope of the hypotenuse of the triangle on the unit circle. Okay, so if we are looking at our unit circle, and we go back there. So on the unit circle, for example, if I'm at 0 degrees, remember that y over x would be 0 over 1, which is just 0. If I'm at 90 degrees, y over x would be 1 divided by 0, which is undefined. So remember we talked about slope at 0 and 180 is 0. Slope at 90 and 270 is undefined. We also talked about the slope at a 45 degree angle. So if we look at a 45 degree angle, we notice that x and y are the same value, or they might be opposite numbers. So the slope at a 45 degree angle is either going to be positive 1 or negative 1. So those are really great key values to plot for our tangent graph. So let's remember slope. So 0, 180, the slope equals 0. 90 and 270 is undefined. And then at 45 and 225, slope equals 1. And at 135 and 315, slope equals negative 1. So these are the key points that I'm going to be putting on my tangent graph. So let's start where places where the slope is 0, at 0 degrees and at 180. Now if we keep going around the circle back to 360, that's the same as 0 degrees, so that would also be a slope of 0. If we went around the circle backwards, so here's forward to 180, if we go around backwards to 180, that would be negative 180. So negative 180 and negative 360 are also places where slope is 0. Now, places where slope is undefined means there isn't anything there, so we have to put a barrier on our graph to say we can't have a y value here. So at 90 and at 270, we're going to have a vertical asymptote. Okay, so barriers here. At 90, 270, negative 90, and 270. Negative 270. Now we'll put in the places where slope is equal to 1. So 45 degrees has a slope of 1. 225 has a slope of 1. 135 and 315 have slopes of negative 1. This same pattern will continue as we go backwards. Negative 45 is the same as positive 315, so that would be negative 1. Negative 135 is the same as positive 225, positive 1 slope, and so forth. We can continue this pattern. Now what happens when the graph gets close to 90 degrees? What happens when the x value gets close to 90? What happens? What does the graph look like? So let's check out tangent values that are close to 90. So I can do tangent of 88, for example. And we get 28.6. That's an interesting trig value. We don't usually see one that big. Tangent of 89 degrees. Oops, didn't put my parentheses in there. 57. Tangent of 89.5. 114. Tangent of 89.9. Notice I'm getting closer and closer to 90. Now if I do tangent of 90, it says undefined. So I can't do tangent of 90, but I can get close to 90. Let's do tangent of 89.999. 57,295. So my tangent value keeps going up. Tangent of, I'll lower this down a little bit so you can see, tangent of 89.999999. Okay. Now this is 5.7295. When you see this E, that means times 10 to the 8th. If I copy this and paste it down here, in other words, I've taken this decimal place and moved it over 8 places. So this is actually the number 572,957,795.13 blah blah blah. So we can make our tangent value as big as we want it to be just by making the angle closer and closer to 90 but not equaling 90. So what does that look like when we draw it? It means that the line curves up and runs along the asymptote and goes up forever. And the farther it goes up, the closer it gets to the asymptote, but it never actually touches it or goes over it. Notice how the curve curves up, upward curve above the x-axis and a downward curve below. Very nice smooth curve, very elegant looking graph. Has these nice swoop curve up and a swoop curve down like this. So very nice elegant graph. There's not really any jog in there. Now some of you may recognize it looks really similar to the cubic graph, x cubed, y equals x cubed. The difference though is that each of these little curves is contained within the asymptotes. It can't cross over. Whereas in the x cubed graph, the x-coordinate keeps moving outward at the end of the curve, and so eventually I could go, as far as I wanted to the left or the right on the x-axis and go way up, and I would find a y value because that curve continues to go out. But if I'm only looking at this middle curve, the whole graph is contained between negative 90 and 90 for this middle section, and this whole section is contained between 90 and 270, and it can't cross over into the other section. So that's the difference between the tangent graph and the x cubed graph.